Imagine you're in a classroom with other students. Suppose that there are, say, 30 people in the room, and everyone announces that they want to have a birthday party on their birthday. Since you're already imagining this, let's expand it just a slight bit more. Assume everyone in the classroom is friends with each other. So they would get invited to everyone's birthday party. And this begs the question, will any two birthdays be on the same day? Why? Well, since everyone's friends, they're going to want to go to everyone's birthday party. If two of them are on the same day, well, you can't go to both, or you'll miss out on some of it. This is known as the birthday paradox, and it is spooky. As there are only 30 birthdays happening, since there are 30 people in the room, that can range over the course of an entire 365 days, it doesn't seem like any of them will crash. Or will they? Whoa! We are a math channel. Mathtastic is our name, so let's try and solve this mathematically. Just a warning, this technique requires a sufficient introduction to probability. If you don't know what that is, it's fine, and I'll explain it in my next video, so please check it out when available. Anyways, back to the birthday paradox. So, to solve this, we use complementary counting. If you don't already know, this method finds the answer by finding the cases that don't work. Now let me explain it slightly. I'm just going to elaborate on it. So suppose you had a jar with 10 marbles. And some of them are red, some of them are green, and some of them are blue. And you wanted the chance that when you pull a marble out of it from random, you want to get a green or a blue. Well, instead of finding that, we could instead find the probability that we don't get a green or blue, or get a red, and then do the total amount of ways minus that. That doesn't make sense? Well, you can check it out in my video, but hopefully that will be sufficient. Anyways, let's begin. So, we want the probability that no two birthdays land on the exact same day. First, let's start with one person. Well, actually, this is pretty simple, because if there's only one person, then the chance that no two birthdays land on the same day is 100%, or 1, because all of the birthdays are the same, since there's only one of them. What if there are two people? Well, the second date can't be the same as the first one. Using our formula, we will get 364 favorable options and 365 total options. And 364 over 365 is approximately 99.7 chance. In other words, for every 1,000 groups of 30 people, 997 of them will have, or groups of 2 people, 997 of them will have those people having different birthdays. Now let's do it with 3 people. The idea is the same. The first date can be anything, because it won't be the same as anything. The second date has to be different from the first one. The third date has to be different from the first 2. So we get a 364 over 365 chance for the second person. And since the third person can't be any of the first 2, there are only 363 ways. So it's a 363 over 365 chance for the last. Multiplying, we get about 99.2%. This number is smaller than 99.7%, though not large enough to make a difference, seemingly. Another way we could do this is we could take the previous probability right here, and we could just multiply it by the chance for the third person, or 363 over 365. Anyways, we get the idea now. So let's skip all the way to when there's 30 people. We would have this over times that, and we would keep going on and on and on until we get the 30th person, which is 336 over 365. And we get about 29.4%. But don't forget, we're not done yet. Remember, we're doing complementary counting. And again, that's like just the total minus. So we're actually doing the opposite. So the probability that 2 people do share the same birthday is 100% minus 29.4, or around 70.6%. And this is why the birthday paradox is so famous. It seems like 30 people is a tiny fraction out of 365 days in a year, but it all adds up. The chance of 2 people sharing the same birthday out of 30 people is more than 70%. Who would have thought? Please note that our calculations are not completely accurate. We did ignore leap years, which have 366 days instead of 365. But our number is close enough, so it really doesn't make a difference. You can calculate this with any good calculator, but I usually use Wolfram Alphas as it's super accurate and fast. By the way, a coincidence is that the smallest amount of people there needs to be for the chance of 2 people to share a birthday is 23. Also, like said previously, if this didn't quite make sense, be sure to check out my video on an introduction to probability coming out soon. Be sure to like and subscribe, and see you in the next one. Bye!